Imagine starting with a blank desk, an STM32 board, a breadboard, and curiosity. But first, you'll learn the basics: how to set up STM32 chip IDE, connect your board, and blink your first LED. This simple how the world of embedded system will give you the confidence to move forward. Next, you will explore GPIO to read button inputs and control digital outputs. Step by step, you'll interact with hardware directly and feel the power of embedded programming. Along the way, you'll also learn how to use that breadboard for safe circuit connections, read basic schematics, and interpret printouts so that every connection you make is correct and reliable. Once you are comfortable, you'll unlock the world of analog to digital conversion, learning how to read real-world signals like light intensity from an LDR or temperature from a sensor. Here, you'll see how datasheets guide you in understanding sensor ranges, voltages, and behavior. Suddenly, your STM32 is not just blinking LEDs, but sensing its environment. From there, you'll dive into pulse width modulation to control brightness, sound, buzzers, and even drive servo motors. You'll see how precise timing turns into practical control, all the while following schematic diagrams to wire everything correctly on your breadboard. Communication is the next milestone. With UART, you'll connect your board to your PC, sending and receiving data to monitor sensor values and build interactive projects. You'll also practice reading sensor datasheets like the HT11 for temperature, humidity, or the ultrasonic sensor for distance to wire and configure them properly. As project grows, you'll need efficiency, so you'll learn DMA, direct memory access, to handle data transfers smoothly, freeing your CPU for more important tasks. You'll also master interrupts, enabling your STM32 to react instantly to external events like motion detection with a motion sensor or a button press, making your project responsive and real-time. Motion becomes your next domain. You control DC motors with L298N and L9110 drivers, stator motors with precise control, and servo motors using potentiometer inputs. Your STM32 no longer just reads the world, it moves things in it. Displays become your canvas. You experiment with 7-segment modules, shift resistors, MAX7219 drivers, dot matrix displays, and I2C LCDs. You output numbers, patterns, characters, and animations, making the STM32 visualize whatever you imagine. By now, you've combined sensing, communication, timing, power, displays, and motion. You're ready for a full project. You create a remote-controlled LED animation display, build a mini film art project using Circuit with an OLED screen, assemble an MP3 player with DV player, an audio amplifier, and construct a distance meter with an ultrasonic sensor and OLED display. By the end of a course, you'll have traveled from beginner to intermediate, with the ability to design and build your own embedded projects confidently using STM32 and STM32 chip IDE. And more importantly, you'll know how to read datasheets, interpret schematics, and build reliable breadboard circuits, which are the true foundations of any embedded engineering.